Hello, everybody. This I'm going to do question number 3 from paper 1, 2023, AS Chemistry. This is all about the experiment knowledge that you have. So hopefully by now you have, or by now people who have done it ages ago, you have gone through the standard solution experiment. So preparation standard solution. So when you did that, you should remember the bits that that they are important to know in this practical, because it comes up in exam papers. So start by reading the question very carefully and trying to absorb the information. A student uses a method to prepare a standard solution of sodium carbonate. Weigh a clean, dry, empty container on a balance and reads to two decimal places. Add about 2.5 grams of solid sodium carbonate to the container. So the next bit you should do is to tip the solid into the beaker and reweigh your container. That's the next bit you should do it. Add approximately 100 centimeters of distilled water to the beaker and stir until all the solid is dissolved. Okay? And then pour the solution into 250 centimeters volumetric flask. After you've done that, you must have add some more water to your beaker and then stir it to make sure you clean up the beaker and pour more water, pour it into the volumetric flask. You must have done that, so to make sure your results are accurate. Add distilled water until the top of the meniscus is level with a graduation mark. So suggest 3 improvements to this method. Right, so once you prepare the solution, you should at least invert your flask 13 to 14 times, okay? That's my view. It's not written anywhere, but it's just like to make sure that your concentration, your solution is completely mixed together. Suggest 3 improvements. So record all masses accurately to 2 decimal places. So you need to weigh and reweigh, so you're recording everything correctly. Then you wash the beaker into the flask after the solution is transferred to the volumetric flask. So that's what I just said a minute ago. You rewash it, you put the rest into volumetric flask. Invert the flask several times after the making solution up to the graduation mark. So here you should invert because it's not mixed together properly. So you need to make sure the concentration of all this is actually the same. 3.2. A student uses the correct method to prepare 250 centimeters sodium carbonate solution into a volumetric flask. The uncertainty for this volumetric flask is 0.2. So you need to know the different uncertainty for volumetric flask, for cylinders, for how do you call the other one? Pipettes, balances. You need to make sure you know what would be the errors for that. For volumetric flask, you only read once. So if you read once, you only got 1 error. A difference to choose is correct math. Okay, so calculate the percentage uncertainty of the volume body sodium carbonate solution. So you have only got this error out of the 250 times 100, which is gives you 0.08%. Let's move on to the next question for number 4. So M is a group 2 metal that forms a nitrate, okay, which is 0.32 grams of nitrate is reheated strongly and decomposed completely. So this is your equation. The mixture of gases formed as a volume of 225 centimeters cubed, 450 centigrades, 101 Pa. Determine the MR of this thing here. Identify M. So there's 2 things you need to do here. The gas constant is this. So you start by saying the volume of these gases, so all the gases here, is for forming 5 mole of gases, is 225 centimeters cubed. First thing you need to do is change that for meter cube, because that's the unit you need to use. You need to change temperature for Kelvin, okay, so by adding 273. And then you need to change your, that you don't need to change that because they usually ask to change 2 things, so that one is correct. It's in P. It's pressure in PA, sorry, I should put PA here. Okay, pressure, this is pressure, pressure in PA here. So then you put PV and RT, okay, rearrange to find N because that's your unknown, because you need to know the MR, so you need to know number of moles. So you plug the equation in and you'll find the moles of your gases first. You've got to remember that. Because the gases is a 5 moles and this is 2, you have to do the ratio N2 to 5 gives you 1.51 times 10 to minus 3 moles. And this is moles of your nitrate. Once you got the moles of your nitrate, you can find them MR. So by rearranging this equation, you got 0.32 divided by moles equals to MR, which is 209.9, not 9 point. Now you know that's your nitrate completely. That's a complete value. So we know that there's NO3 twice there. So you can work out the value for NO3 for 2. Work out the value gives you 124. Okay. Then you take 211 that you just worked out minus 124 gives you 87.9. And that's the value for your M. So M, if you look in your product table, M is SR. So your answers are MR is 211.9 and SR is the answer. I hope it made sense. I went slowly just to make sure you understood what I did. I'll keep asking you, please don't forget to subscribe if you are watching my channel, because I will carry on adding stuff. And if you're doing the A-level chemistry, it should be useful to you, whatever you're doing. If you like my channel, please subscribe and tick the like button. Thank you so much for watching me, and I'll see you in the next video.